first theme that I'd like to discuss is where, we've heard quite a diverse set of different ways in which data science was currently being applied to different climate problems, together with some description of the variety of climate-related problems that we have. So a little bit of discussion maybe around where people saw additional opportunities, or where they spotted ideas where they could see things connecting together that hadn't been currently suggested. I thought we could have a little bit of a discussion around that. There were then a few things that either speakers or questioners brought up that were, if you like, broader considerations, either around, the need to get the language right to communicate between different groups, or there were issues that people discussed around, or highlighted around the misapplication of techniques. There are clearly broader issues. There was a discussion at some stage about whether or not there's ways in which we can structure things to democratize this a bit more and to allow more people to become involved, et cetera, et cetera. So there's something around broader considerations. And then finally, just a little bit about, what could do as a new community in terms of next steps. So that's the plan. Can I start off by asking if anybody's got any questions that they want, that have risen from the talks that they've heard that they haven't already asked, that they'd like to highlight? Yeah.
So I was impressed by sort of the style of classification stuff that Prabhat was talking about, and in effect that really would be beneficial to the community only, I feel, if it's applied or easily applied to an awful lot of data. And so the sort of, we've heard a lot about how CMIP will all be distributed, and effectively that's sort of the raw data. And then, do you think there's any use for sort of the post-process or elements of post-process data? So, say, Prabhat's tropical cyclone maps also being hosted on big distributed servers, or is that something that would need to be run more locally in the long term?
Well, I'll just a couple of quick comments. So post-processed products in general do go into archives as well around the place. So in that sense, yes. So the slightly more interesting question, I think, is you said these tools are useful if they can be widely applied. Well, they're useful, full stop, but it would be better if they were widely applied. Yeah, okay, so in part, that's the sort of thing that the national labs in the US and NCAS in the UK, that's our raison d'etre, and to see if we can put the pieces in place. But there's kind of a chicken and egg problem in the sense that doing the stuff at scale is expensive, needs a lot of lining up. So it really requires the community to bang on the door and say, actually, this is something we really need, and here's the science benefit of doing it. So it's kind of a bit scarily easy to start a conversation with a cool tool. I'd really like to apply it to this data, but particularly if it's a big resource, we have to say, and this is what we can do that we can't do. So that's the hard part of it.
Yeah, and actually, that was something that really struck me as well. And it's not just necessarily what the climate is, what ultimate end societal goal are you trying to, or societal question are you trying to address with this technique? And that strikes me as being a very important thing. Otherwise, in this area, it's going to be all too easy to get to just get obsessed with playing with the latest toy. But we need to keep an eye on looking in the other direction as to what the right tool for answering the right question is.
I guess it's also about the kind of evolution of research. I mean, I think in your analogy, you're suggesting that having we do the CMIP6 runs, we process the data, and then we put it out there, and then that's kind of like the level 0 satellite data, if you like. That's the starting point now for everybody, and the reason we got to that is that nobody can be bothered, or nobody wants to run their own climate model. So we'll just produce a whole load of climate data and we'll make it available for everybody to use, and then it's up to the researcher to add their secret sauce to the analysis, and Prabhat's got great techniques for doing that, but somebody else might have some some other ones, and so maybe we're at that level. We've got the basis for, we've got all this climate data that can be analysed, and then it's there for researchers to apply their techniques to it. Now, I guess if deep learning took over the world, then maybe there'd be another layer built on that when you've got the broad data and then you've got the deep learned analysis, and that's made available for everybody, and then somebody's going to put something on top of that. But I suppose it is about pushing forward that boundaries of research and where you start from the basis and then the extra stuff that you want to add. I don't know if that's clear. Yeah.
So I think in the discussions with the ESGF people at Livermore, I think it's become fairly clear that right now these models are fairly passive, right? I mean, all you do is specify data and download it. That's not, you need that capability, but being able to launch analytics jobs on entire archives, that's the powerful thing that people are looking for. So the question is, who owns that problem? Should one launch a job that requires whatever, 100,000 core hours or 1 million core hours? Who's going to be responsible for that allocation? How do we stage that job, so on and so forth? So I don't think we have an easy community-wide solution for that yet. But I think at least for us in the US, it's clear that that's where we need to go. Now, just on the deep learning side, certainly you can a network, a trained network, and then all you're doing is inference. So the challenge is, how do you move the data from wherever file system you might be on to wherever the computer is, a GPU or a CPU or what have you. So in many ways, inference is straightforward and easy compared to training. But it's a paradigm that can be applied easily.
Right. No question here. No, I think it's better because then people online. Oh, sorry.
Yeah, go first.
We'll ask 2 questions and then we'll get them.
Okay, sorry, I took your spot. So we talk about level 0 data, which are already massive, and I think the climate community is ahead of the Earth observation community. So is there a paradigm to, mimic what they've done in the Earth observation community? Because right now I don't think I have the same classification with all the satellites, version 1. So that's the first step. We need to get to know the data and access the data in the same way. Second is that we haven't talked much about often one data set, say sea ice thickness and concentration. A lot of data, satellite data, are reinforcing each other. So there is, covariance matrices. Things are related, for unknown reasons often, but it is very informative nevertheless. So a lot of this work at multivariate analysis and so on can be done at least at a lower resolution, I think. So do you plan, in a sense, to have a poor man's version, but of everything? Is the idea of every satellite product or proxy or data set?
Let's do that, and then we'll come and ask you. You can ask a question.
It's a little more complicated, I think, in satellite data in the following sense, which is that radiances are directly comparable to one another, and some people would argue that you have to worry about the calibration of the instrument in order to do that. But after you push those radiances through a retrieval algorithm, what you're getting out is, even if those two products are called the same thing, they might not really, quote unquote, be the same thing, because the way they were inferred from the radiances automatically builds in certain kinds of exceptions and a million different assumptions. So just because two things are called temperature doesn't mean that, in the sense that you as a user care about, they really are both comparable to one another. And I think one thing the satellite community, I think, agrees in principle would be nice, but is nowhere near accomplishing, is using a common standard for uncertainty quantification for that. For example, if two different satellite producers of temperature data could decide what the target of their inference is, exactly which flavor of temperature, and down to every detail of the retrieval algorithm, then maybe they would choose to process in the same way, or maybe they wouldn't, because sometimes that's just not practical, but they would at least quantify the uncertainties in their products relative to a common baseline. And then that would give you a means of understanding how these two things are alike or not. And better yet, they should really do a cross quantification, so that there's not only the individual variances on the product or the individual uncertainties, but there's a cross covariance measure about how far, to what extent they're the same and what extent they're not. That at least is kind of one problem the modeling community doesn't have, I don't think. I think when something's called temperature, it means temperature, and there's only one temperature across models.
But it strikes me as though there are some themes that have come out today in terms of potential research topics which do potentially intersect in different ways the different types of climate information, if you like, that we have, and uncertainty quantification and moving beyond what is done existingly in terms of uncertainty quantification and drawing in and actually, some of the advances that have been made recently in the theoretical side of uncertainty quantification seems to me like an area where there is opportunity to make progress, and there are new questions that are being raised up as a result of some of these, new data science looks at the field.
To say there are opportunities is a glass half full way of looking at the problem. So I like that.
Thank you. This might fall a bit into your kind of broad themes category, but with the different systems that we've thought about building, as with any engineering system, there's potentially a tension between richness, that's understanding the climate in great detail, and what you might call responsiveness or availability of that system. That is, you might want your calculations to update very quickly when new observations come in, or you might want to have on-demand bespoke downloads of certain things that have been calculated. So, and the right balance depends on the application, I guess. So I'd just be interested to get general thoughts about in your work how you think about that trade-off and make those kind of decisions when you're thinking about what to prioritize, if that makes sense.
Can I make a quick comment and then I'll hand it over? I think one of the difficulties that we face at NASA is that apart from the research that we do ourselves, our job is to make data that are available to the entire scientific community. And it's very difficult to walk that line you're talking about when you have an entire range of users who need the system to accommodate that range of potential answers to your question. So I think some of what you see is that we've ended up in kind of an average position that suits no one, right? Because if you can't suit everybody. So that was part of the impetus for starting to think about how you might give users more control over what they're getting.
I think that it's just a small point, but maybe some of the things I said when describing the different models we've built might be a reflection of the situation you describe. So the Earth system model is like the physical model, and it has extra processes built into it. It's a more sophisticated climate model, and yet for some of the experiments involved in CMIP6, the experimenters are still opting to use the low resolution version of the physical model because there are things in the Earth system model that do not affect the scientific questions that they're trying to answer. So they have some understanding of the sort of science they want to do, and they can work out which of the models is better. Similarly, I know, for example, for the cloud feedback experiments, they've opted to use the physical model, but they are opting to use it at a low resolution. They see that there's nothing to be gained by going to that high resolution where you get that extra detail in the atmosphere and the ocean and stuff like that, but there's nothing to be gained in terms of the scientific questions that they're asking. So that might be an example of the sort of horses for courses type thing that I think you're concerned about.
Yes, it sounds like your solution there is to make it clear it sounds like your solution there is to make it clear what the parameters of the system are and then to let the users choose broadly.
If that's what we've done, that's what we did, yes. Yeah.
So I should say some of the selection choices in response to both of the last questions are at least made by the scientific community. So most large programs in the in the UK academic community essentially are now required to have a data management plan. And people always think about that being the bit that says, oh, I've got to do something to write down what I'm going to do when I'm finished. Actually, it's about the whole project, including what data do I need. And sometimes the data management plan in the UK will get us to acquire data sets, put them into the archive, make them available to everybody else, as well as solving the solution for that particular research project. So to some extent, the peer review process, in academia at least, is saying, okay, we respect the requirement for inputs as well as outputs, and therefore resource it as well. And so at some point, I then have to, or my group have to, balance the competing resourcing requirements.
I think that one comment I'd like to make is that I think the sort of facility that would be very useful to someone like me is a level less complicated than what Amy was talking about this morning, but the ability to go directly online to the different modeling groups and do the manipulations I want for myself. So, for example, if I wanted, because I want to do some extreme value analysis of precipitations, it would be very, very useful to me to be able to calculate 5-day annual max precipitations for every grid cell, for every model, no, perhaps not for every grid cell, maybe a selection of grid cells for every model, and just download that data. What I have to do at the moment is to download the entire NetCDF file and perform the calculation. And personally, I use NCDF4, which is the R program to manipulate NetCDF files. I know how to do that on my own local machine, but I still have to download the big data set first. And it would be very useful to have some facility to do that remotely.
Move back to the UK. I mean, seriously, I mean, the solution to that problem in the UK is Jasmine, and that's what it's for, and that's why the UK government has funded us to have a large facility, because we have the complete CMIP archive and the ability for you to log in and run your own R program. If you don't like our R, you can come into the cloud part of the facility, install your own operating system, your own software, and run your program on the data, and then download to home. That's precisely the use case that we figure is no longer, hasn't been for some years, solved by saying to everyone, download. Now that's okay, because we've made a decision that that's what we as a nation want to do. The problem arises for people in other countries where there is no such resource available, and they then have to either find some friends where there is resource, or it is problematic because those people are also the very same people who are hosting data for other third parties and don't have the compute themselves to support your use case.
You can download that one from the ETCCDI in Canada, and it's all pre-computed.
Okay.
Yes, it's more a clarification of what you had just mentioned about this. Look, I'm more interested in the practical things more than solving problem, more than do research. For example, I have a project in Turkey, and the idea is how, let's say, I can link climatology with environment, with, let's say, identify problems, locally problem where the people they can stay and live. This is the question of migrants. Now, we have developed this type of Earth observation data cube, and the idea is of extracting the information from any sources, put in a data cube, running this advanced tool like machine learning in order to come with a practical solution. Now, in this context, how can I use, let's say, all this type of facility that you discussed today?
So right now, maybe, if you want to, say, use deep learning capabilities at NERSC, I think the challenge for you would be that you would need to be a bona fide user that is contributing to the DOE mission. I mean, that's what the supercomputer is for. So the DOE has a certain charter, and if you can submit a proposal which is aligned with that mission, then you can get an allocation of compute hours. Once you get onto the system, then you can module load deep learning, and the code is there, right? So likely either you'll need to download your data, or if some of the data set is local, You can stage that in, and the deep learning capabilities are there, and you run the tool. But if you do not have a project that's DOE mission aligned, then it's much harder for us to support you.
Look, I have also the facility of using this big company, like Google or IBM, they provide everything.
Yep.
I mean, so what is the advantage or the competitiveness, we can say?
Well, take first things first. A data cube is effectively just is the wrong word. A data cube is effectively where you've regridded a bunch of different data onto the same data. That's essentially what you're talking about, isn't it? That you can then because you've got everything on in the same format, the same grid, you can apply your tools without worrying about the messiness of all the input data. So that's the huge advantage of a data cube. So then the question really is, where can I where can I do the reformatting? That's part one. And part two is, having reformatted it, where can I do the calculations on my data cube?
Your distribution, I mean, you see this parallel computing is open source to the analytics.
Yeah, sure. So the answer to all of these questions are you can do that anywhere where you have access to the relevant computing. So I'm not quite sure what part of the problem is problematic. Is it the resource to do the reformatting in terms of the people, or is it the compute resource to do the...
No, I think it's the computing aspect. It's because I think we need to develop some... the old idea is you need to really develop some kind of roadmap, starting from the problem, as we mentioned before, going to the data that you needed, going to the platform, the analytical tools, and back again with an iterative, let's say, solution. And this is, I think, should be in a holistic way solved the problem.
Yeah, but there is no generic solution to that problem, right? So, I mean, you will need some specific data which you will need to track. You will need some specific analytics tool that likely you'll need to develop. So as a computing center, what we can provide are data management tools, data analytics tools that work at scale. So those capabilities are there, but then you as the user will need to customize it to your use case.
Can I broaden this discussion out just a little bit more and actually tap into some of the questions that were being raised about the democratization of this and so forth? So in a way, most of the presentations today, we've sort of, I think, had in the back of our minds that if there's an end user, it's been a pretty sophisticated academic end user, right? Not always, but in most cases that's been the case. And an academic user in a well-resourced country, in a well-resourced institute. We are talking about climate information here, and a lot of that climate information, as we're moving more towards being able to provide regional information around future climate projections at a local scale, is going to be potentially useful to a much broader set of end users who are less sophisticated, maybe in developing countries with less of infrastructure. If we're finding it difficult enough to provide information to very sophisticated users, what's the future strategy for providing this information down to be usable to those sort of...
So excellent question. So this meeting is, speaking personally, I targeted the material for data science at the expert end in the UK. What are the opportunities with what we have here? So had I been giving a different talk, as you recall, I have a number of hats. I may have been talking about the way that we created the Jasmine and Cedar environment to target different classes of users. And I like to talk about the kind of the number of doors that you have for the different communities. Back in the day, we had upstairs and downstairs, and different people came in through the different doors. Now I think from the data point of view, one of the things we've tried to do with Jasmine is to say, for the expert users, we will have all the data on disk or near line, and you can take out your favorite Swiss Army knife tool and get right down to the data at level 0 or wherever you like to be in the data. But then there's another door, which is the door to come in where there are data products, where you can still come in and work with the data products. And there's another door, which is the software as a service, the portals, the KNMI Data Explorer type tools, where we're saying, okay, here we've pre-packaged and pre-canned some things for you. And I think and at that level, you're saying that those are that we have some of the pieces in place for some of those communities. The trouble is that weirdly, you might think the resources required to support the expert users at the petascale are the expensive part. That is the expensive part in terms of kit. The expensive part in terms of people all lies at the, if I want to produce you a portal for your community, I'll put several people on it and I'll do it. But people for your community over there will need a different set of people. And so the problem moves from being pretty much a hardware problem at scale for the experts to a people problem at scale for the non-experts.
But are there opportunities to automate that people bit out, to remove the people bit from that part of the equation? I mean, it's an obvious.
Well, so I would clearly the opportunity for, one of the reasons I gave an example of machine learning to clean up data series, and one of the reasons why I banged on about the importance of formats and standards is those are two of the things that you can do. You can use machine learning to clean stuff up. Great, that's one of the things you need to do. But at the back end, and particularly most of the things we're talking about for climate are unfortunately data archaeology. And did we have enough data about the data, then we could use machine learning. But what I was trying to say with my NASA Ames format example is often I have a lot of numbers in a file with not enough context to give any tool enough information to work with. The only thing that's going to be able to go in there and go, they wrote S, and it looks like it's a profile of something in the middle of the atmosphere. That could be sulfur of some,
Can I ask a really practical question? So I was involved with the UK climate risk assessment last time, and I did people in the built environment, and I got rather interested in the effects on coastal communities of sea level rises and storm surges under climate. So that's a really practical question if you live on the coast. At what point could you help people decide what will be the earliest and latest time to leave their coastal house?
Do you want to try and answer that?
Are you anywhere near that kind of answer?
And I have a follow-up to that. Would it matter if you used CMIP 6 or 5 or 4 to do that?
Okay, so I'll try and answer. Try and unpick the various. So there are two parts of answering. One is about the sources of uncertainty, which you're essentially asking about. And the other part is going from a climate prediction to to something which is effectively an engineering prediction, which is when is this cliff going to be unstable or whatever. So I think what we're trying to do a little bit today is I think there are quite a lot of opportunities for us to be able to go from the weather to the engineering problem with machine learning and other approaches in that space. And I think that's going to be a rich vein of opportunity. The uncertainty around the climate prediction comes from, I'll see if I can do this off my top of my head, three sources. You've got a projection. What am I projecting? What are the inputs to my projection? Then I've got initial condition, probably doesn't matter over a long time scale. But most of the uncertainties sit inside coming down from the global scale to the regional scale. Can we do that well enough? High resolution. But the really biggest part of this is the human bit. And so I would say the Dutch have a quite good approach to this. Instead of saying, can I project the range of possible futures in the earliest and latest, they'll say, okay, what are the kind of scenarios which are consistent with a high engineering risk, and what are the scenarios which are consistent with low engineering risk? What do they look like? Can we understand how they will play out? And then what are the decisions we will make based on that information? Rather than try and effectively predict the difference between 2030 and 2050, far more interesting from an engineering point of view is to say, what am I actually going to have to do when this happens?
You've got to be able to say when you're going to do that thing. Because if you're going to make an investment to defend New York, for example, or Shanghai, then you've got to know when you're going to take certain classes of action.
So the canonical example again from the Dutch is when do I build the dike and how high do I build it? Well, if you know you've got to build it so high because that's what's going to happen, you can build it with a wide base and only as high as you need to for now. So that's where knowing the engineering outcome gives you the, okay, right, well, I'm going to have to deal with this. I've got to deal with this bit now. But rather than just do what I need to do for now, I'm going to prepare for the fact I have to do the long.
I think there are other issues as well around this. When we're starting to move, or if we start to move towards providing information that people will make decisions on that either have very large financial implications or potentially have implications in terms of people's lives, then we enter into another whole game in terms of, what's the reliability? It puts a different dimension on the uncertainty quantification. What's the reliability of that information? What's the liability associated with that information? It starts to, bring into play a whole set of wider questions that we probably haven't previously had to address to the same extent in the community.
So are they addressable? Sorry to keep asking, but
Do you want to?
where's the practical deliverable in this panel? Who's going to deliver the answers for people? Which is what Emily asked in the first place, if you like.
I have maybe a partial comment on that. I don't have the answer, of course, but one thing that's become more clear to me as time has gone on is that both in terms of decisions like that, when should I evacuate, and in terms of science, I think it would be good if people thought more in a decision theoretic way about these problems, which is to say that you need not only to think about the uncertainty that your model, in the model results you get, but what the consequences of making your decision one way or the other are. I was at a meeting last week and somebody was giving a talk about the explosion of the Space Shuttle Challenger and some of the analyses that they had done and not done very well that potentially might have changed people's minds about whether to try to launch that way. And it was a great example of where there was no thought as to the consequences of being wrong as part of the analysis. So if all that was sort of a regular part of the analysis, that might be helpful, particularly in that scenario. But even in the science scenario, notice that when people write scientific papers, they don't, some do, of course, but often there's no formal hypothesis test. It's all kind of in an exploratory sense. And I don't know how easy it would be to make that a little more hypothesis testing oriented and then put a decision on top of that. The decision to accept or reject a hypothesis, if people thought a little bit about what the consequences of being wrong would be in those, and I don't know that is an easy thing to do for a scientist who's just interested in deciding whether their theory about how something works, and that's the intent of their analysis, that they can prove their theory or disprove it. But where does that lead? What is the next person going to do with that information, the person who tries to build on your analysis? What are the consequences of being wrong?
So we're starting to run out of time. We could, of course, continue discussions over drinks. So I'm going to ask one more question here and then allow the panel to have any comments or things that they wanted to raise that haven't been asked about.
I just want to come back to the point you were making about the democratization of this data. It seems that there's a sudden distrust of experts at the moment within the general community, and the deniability of climate change theory and a lot of the theoretical sort of evidence that's being produced. I don't know to what extent the new generation of climate model is going to be more convincing to people who are doubters or deniers of climate change. Is the answer in sort of like more democratization involving more people in sort of like consuming and perhaps even contributing to this data set? It seems to me that there's an explosion of available data now with sort of like Internet of Things and mobile devices all potentially collecting and presenting this information, is there any scope into, I don't know, stepping into the wider world and making a lot of these tools more generally and perhaps even commercially available to the general public?
I mean, maybe I'll just comment, and maybe Brian can perhaps step in, because he actually one of the examples that Brian mentioned was a project, the Old Weather project, that has been running, that's involved people in transcribing those old weather records, which has been a hugely successful project, hasn't it? It got a lot of people engaged and involved, and there's been a long-standing climate.net project has been around for 15 years or so probably now, allowing people to run sort of low-grade climate models on their computers, and it's provided a very valuable data set for researchers as well. And so my impression is that there are actually lots of opportunities for those sort of engagement projects to both draw in interested new audiences, but also provide valuable research data as well. So I think that's definitely a productive avenue. Want to add any more, Brian?
Yeah, well, that's, sorry.
Yeah.
I mean, that's a good example of using human bodies and spare resources to answer difficult, well-defined scientific problems, like running a climate model on a larger machine that you have available. And I think to some extent, I was involved in the start of climateprediction.net. I think to some extent, the fact that people feel like they're involved in tackling a scientific problem, which is doesn't exist in isolation. It's not some sort of theoretical type thing about whether or not there's a Higgs boson. It's a real scientific problem whose answer has implications for the way we live and the decisions we make about the way in which we structure our world. I perceive that the people who got involved in that were concerned about that. There's a huge amount of public concern about the climate and climate prediction and stuff like that.
And I don't see it's that much of a leap in the sense that everybody is always checking the weather on their phone. So actually giving an extra bit to that sort of like level of interest could power a lot of the things that you're doing.
Right. So firstly, I was probably going to say exactly what you said, Emily. So thank you. So I'll just add one more point. I actually think weather apps on phone are actually really problematic for climate science, which I'll get to in a moment. But I think your substantive point is, what can we do to democratize doing and understanding of science and belief of science? And to some extent, climate science is bedeviled by the politics as well as the science, and so for some people there is no answer to this question. But for others, it is just getting engaged with and working with things and understanding really what we can and can't say about risk and what climate science is very confident about what's going to happen to the climate. We're pig ignorant about what the human response should be to that knowledge. And it's the honesty of understanding that we can do quite a lot of science with the physical climate system, but the social engineering, the social decisions, and how society responds to that information, the risks, the decision-making processes, that's not me as a climate scientist. I'm one of 60-odd million people in the UK and shouldn't have any more say on how we respond. I should be believed a little bit on what might happen. Okay, so that's that. I think that we really just need to make a much clearer distinction about what science is saying, and then and therefore what we do about it being a different point. Just coming back to the mobile phones. I mean, most everybody in this room's probably got a weather app on their phone. Can I just do a small show of hands? How many of them have got a Met Office weather app on their phone? Right. How many have got the BBC one? And how many people have got the bog standard weather app that came with their phone? Right, so the bog standard weather app is probably giving you really low resolution American forecasts, which are probably good for the whole average of England if you're lucky. And then what's going on with the BBC and the Met Office is kind of fun, but from my point of view. But nonetheless, what's problematic is three people sitting next to each other with three different phones with three different forecasts going, well, they can't even get the weather right. And so one of the things that we have to do as climate scientists is really hard on what we've been talking about today, the difference between weather and climate. It's actually much easier to get climate right than weather, but we have to get that across.
Right. I'm going to close off the discussions now, but I just want to give the panel an opportunity to say some last comments, if any of them want to each. So perhaps we'll just run down the panel. And I guess those three questions that I sort of started off, where do you see their opportunities? Are there any other broader contexts we ought to be considering? And what do you think the important next steps are? So you don't have to answer all three, but I'll pass it down for final comments.
So maybe I think just touching upon the last question and associated broad theme around scientific reproducibility. So I do think that as modern contemporary scientists, we owe it to ourselves to make sure that our workflow is reproducible. So making sure that really anyone can pull up a piece of code, the software environment that it is executed in, and a data set and get the same plot. I think that functionality is important going forward. And I think that should address some of the credibility issues maybe that have come up in the past. Now, the amazing thing is that much of that technology now exists at this point in time. So in containers, we have an opportunity to encapsulate the environment. In Jupyter Notebooks, for example, we have a possibility to get a handle on the code. The data part tends to be problematic, and I think multiple speakers have talked about that on how do we get access to that data. But I think once we solve that problem, I do believe that this challenging problem of reproducibility can be addressed. Anyway, so that's just one observation.
So following the theme, I think to add but not contradict anything you've just said, one of the things we talked about earlier on is provenance. So I think one of the other important pieces is, as a scientific community, we need to do much better at with any data product, being much clearer about the provenance, how this data product was produced, what we know about the uncertainties and the constraints on how we produced it, and sometimes what we don't know about it. I think those are things that we do when we're good scientists in our papers, but we don't necessarily make sure the paper and the data products are linked in ways that make that easy to use. So that is the one, if you like, big scientific avenue that we haven't really, we've all alluded to a bit today, but particularly in this modern data science world, one of the things we need to do is ensure that when we use these new techniques, that where possible we propagate the uncertainties through them, and if necessary we develop new techniques that have better understanding and better knowledge of how the machine learning came to its conclusion, because that XKCD figure I showed at the end is true in a good and bad way. I think we really need to be very clear about how we get to our answers.
Thanks. I'd like to make a comment by willfully misinterpreting what you say about community. I know what you mean is, can we make these tools available for non-climate scientists? I'm going to pretend that what you really meant was climate models are very complicated and difficult things to build, and as I showed in my picture, they rely on getting right a lot of different processes which no one person or no one research group or no one institute can hope to master. So people who know a lot about the atmosphere don't know very much about the ocean, and people who know a lot about atmospheric chemistry don't know a lot about ocean biogeochemistry, for example. And really the future of developing these models is to get together in a community, developers from different backgrounds, from different institutions, and for each of them to build the best version of the component that they can, and then put the whole thing together into, we'll call it an Earth system model. That actually is the development model that we used for the UK Earth system model with the Met Office and a variety of different NERC sites around the country. In collaboration, but it's also the development model that's been used by the Community Earth System model. I mean, the Community Earth System model sounds better than the UK Earth System model, but because it emphasises the fact that lots and lots of different people from different parts of different scientists have been developing it, and I think that just does reflect the fact that these models that we're building are becoming more complicated, and we need to work together to push them forward. Thank you.
Okay. I guess I just wanted to remind everybody that there's more to data science than just looking at the geophysical variables. So in the last part of this morning, I talked about thinking about the model as data. Another thing that comes to mind is I wonder if anyone has looked at what was accessed in the CMIP5 archive and tried to predict what the user behavior will be, and predicting variables that have a low probability of being requested. Maybe you want to make different decisions about those rather than others.
I can actually answer that. We have,
Okay.
and we are.
Yeah.
Yes,
Yeah.
we have and we are.
Okay.
Not all
Okay.
variables are equal.
Right, right.
People are more interested in temperature for some reason than the amount of plankton in the bottom of the ocean.
Yeah.
I don't know why.
Yeah. The third example is the deck prescribed runs. In some sense, it sounds like be careful what you ask for. Now you have, I mean, if the vision is achieved, you'll have this very consistent set of runs across all the models. I suspect they're going to be different for different models, and so then when you go to the specialized MIPS, somehow you want to take those into account because now you know about them. Yeah. so that's the part about being careful what you ask for. But again, it's another data opportunity. It's a way to study models in a different way. So.
So I'm going to go down a slightly different road, which is that I wonder how it might be possible to encourage scientists and climate modelers to know more about data science. Because my feeling over the last number of years that I've been interacting with that community is that some questions never get asked because people only ask questions that they have the tools to answer. And because not in every case, of course, but in many cases, people are still using statistics from the 1950s and sometimes earlier. Whatever it is that the software package IDL, which is a favorite of my science colleagues, whatever canned statistics are in there is what people use. And so they're kind of trained to ask questions about average behaviors. And the whole idea of gridding as a way of reducing the size and complexity of your data set, because you simply can't operate on anything bigger, is inherently destroying information. And I would like to collectively wonder, maybe with this group, what could be done to bring the level of practice at least to 1980, in the way that climate model output is analyzed and compared to observations, for example. So that's kind of my closing thought about the day.
And Brian, did you have a quick comment on the analyzing the user requests?
Quick word. So our colleagues in Germany have done a fairly comprehensive analysis of what was the most popular and most downloaded data sets, and that's been used firstly to decide what we'll try and replicate around, so that at least the larger centres will have those data all in one place, so that will help. And it's also being used by the modelling centres to prioritise what they actually deliver. And given that we're looking at something like 20 petabytes or something for the global, where we're going to try and have a complete copy for two reasons. One, for the UK users, but the other is in partnership with DKRZ, we're going to try and persist under the auspices of the IPCC Data Distribution Centre, a copy of record of CMIP6. So a lot of that will be on tape. Choosing what we put on tape is going to be driven by what we know. Yeah. Since I've got the microphone, I totally agree with the issue around tooling and behaviour, and that's one of the two motivations for why I talked a little bit about libraries. In fact, I skipped that slide. I was in such a hurry at that point. But one of the things I think that, the two kinds of workflows we deal with are the one-off workflows where people will put no effort into doing it because they're just exploring something, and the repeated ones. And in the first case especially, I think there, if we can give them really good libraries, much better than you get from IDL, and give people training on how to use these, this is going to be key. They're going to need to do it to get the performance because the data sets are so big, so they're going to need libraries that do parallel stuff. What we need to do is get the right stats in there at the same time, rather than later.
I would like to say a couple of points on this. So, because that's the Google engine model, right? They have the, sorry to be rude, or because they're not there, the private sector, so let's represent them. There is data set and algorithms on the same platform. One outcome of this workshop was in my mind when I wrote it, that we would participate to this democratization, so in a small way, in a sense. So I would ask everybody here, and in particular the panelists, to give me a set of their favorite, portals, their favorite algorithms. That it's a bit childish, but in a sense it's important, or direct me towards existing such sites. So I think that will go some way into bringing us to the 1980s, as you said. But it's important to use this workshop as a way to go forward, to direct people to the right information. Because here we have really big experts, but to democratize and to reach even the public, we need to continuously educate and transfer this information. I've been in the field for 8 years, and I know a very small tip of the iceberg of what's out there. I use CDO. We use our own cooking methods. So if we can continue to educate, that would be a good outcome. So I will share that with all the participants. Ask you for your input, essentially.
Thank you. Well, thank you to the panel. I think just the discussion shows what a rich variety of different topics come up when we bring together the challenges posed by climate and the opportunities of data science. So thank you.